Let's talk about probability. On a real simple level, probability is the successful ways of doing something divided by the total number of ways of doing it or it happening. So a good example would be flipping a coin. So this represents the probability of getting heads, or probability of one coin being flipped and it landing on heads. Well, there's only one heads on the coin, so there's one successful way for that to happen, and that is that it lands on heads out of a total of two possible choices, heads or tails. Well, 1/2 as a decimal is 0.5, and that's 50%. Let's look at another kind of simple example. Suppose you have 3 marbles, a red one, a blue one, and a green one. So what's the probability of randomly picking a blue one blindfolded out of a bag? Well, there's only one blue one, so there's one successful way to do that, divided by 3 total possible ways to do it. And when you divide, you get 0.3 repeating, which is 33 1/3%. So that's probability on a very simple level, just simple probability. Now that brings me to this thought. And if you're using the Algebra 2 Honors book from Pace High School, I think it is a Larson Algebra 2 Honors book or Algebra 2 book, page 446, section 8.2. Question number 3 says you have 3 tests, test A, B, and C. And these are the results. So pass and fail. So just to help you read this a little bit, out of the people who took test A, there were 56 people who took test A. 49 of those passed, 7 failed. And those who took test B, 46 passed, 6 failed, so forth and so on. So the question in number 3A is just simply this: what's the probability of someone passing given that they took test A? That's what this nomenclature, or this symbolism here represents. So P for probability, the probability that someone passed given that they took test A. Well, that, looking at the chart here, is going to be, we're looking for somebody who passed test A. So there are 49 people who took test A and passed. So that goes as the numerator out of a total of 56 people who took the test, because if you add 49 and 7, you get 56. And written as a decimal, that's 0.875, and that's 87.5%. So that's how you do that. No special formula or anything, just looking at the table like that. So only 49 people passed from test A who took test A, and so that's 49 over 56. Now, in this textbook, question number 5 asks you to use the formula for this. And the formula for this right here in the book is this. So when you're doing the probability that somebody passed, given that they took test A, that is the probability that somebody passed and took test A, divided by the probability of somebody taking test A. So let's look at that. So if we do that, notice that the probability that somebody took test A is going to be 56, because if 49 people passed and 7 failed, that's 56 total people that took test A. So 56 divided by 154, because if you add all of these up, there were 154 tests. So the probability that somebody took test A is 56 over 154. Now the probability that somebody passed and took test A is 49 over 154, because if you passed and you took test A, there's only 49 of those out of a total of 154. So using this formula, we would do just that. 49 over 154, that's the number of people who passed and took test A, divided by the probability that somebody took test A. So when you divide those, you multiply by the reciprocal. So you write the first fraction down, you multiply by the reciprocal of 150, or excuse me, the reciprocal of 56 over 154 is 154 over 56. And notice if you have this, the 154s cancel and you just have 49 over 56, which is the same percentage. So what this is us using this formula. Notice we got the same answer as if we didn't use the formula and we just used the chart and we used kind of our reasoning here, the probability that somebody passed given that they took test A. So it's the same answer, and it should be. So consider this formula. This is the formula for conditional probability, and that's how you do that using the formula, the probability of passing given that you took test A. So those match up.